Let's talk about something we've all felt. You know, those sudden, sharp, totally out of nowhere pains that make you freeze and just think, whoa, what was that? Some people call them body glitches, and today we're going to get to the bottom of what they really are.
You know the feeling, right? It could be a sharp little jab in your chest, a weird zap in your toe, or a twinge in your neck. It shows up with zero warning and then, poof, it's gone. So what is going on there?
Well, first things first, if one of these random pains has ever made you a little nervous, you can relax. This is an incredibly common thing. It's pretty much a universal part of having a human body.
In fact, we're talking about a huge majority of people. Studies show that up to 70% of adults get these random, unexplained pains. So it's not a sign that something's uniquely wrong with you. It's actually a sign that your body is working just like most other bodies out there.
Okay, so to really figure this out, let's treat it like a little investigation. We'll call it the body glitch mystery. And, you know, the first step in solving any mystery is to define exactly what we're looking for.
So, a body glitch, or what doctors might call idiopathic pain, is basically any pain that fits this description. It's sudden, it's overfast, it's often kind of sharp, and the most important clue, there's no obvious reason for it. You didn't fall down, you didn't bump into anything, it just happened.
And this right here, this is the key that unlocks the whole mystery. We're all taught to think that pain means damage, but that's not the whole story. The truth is, your nervous system can sometimes send out a pain signal all on its own, even when nothing is actually hurt.
So if it's not an injury, then what is it? Well, meet our main suspect. The #1 culprit behind most of these glitches is your own nervous system having a brief and totally harmless little misfire. Let's dig into how that works.
All right, so check this out. On the left, you've got your standard pain signal. You stub your toe, a nerve sends an alert up to your brain, and your brain goes, ouch. Simple. But on the right, that's our glitch. Notice what's missing. There's no injury. A nerve cell just decides to fire. It sends a false alarm, but your brain doesn't know the difference. It still registers it as real pain.
Here's a great way to think about it. Your entire nervous system has this constant, low-level hum of electrical activity running in the background. You can think of it like radio static. Scientists even call it neural noise. Now, your brain is an absolute pro at tuning the static out, but every once in a while, a little burst gets through, and your brain briefly pays attention, interpreting it as a real sensation. That's your glitch.
But these nerve misfires don't always happen in a total vacuum. The plot thickens because they often have accomplices, these everyday things that can make a glitch more likely to happen. So, who are these partners in crime?
They usually fall into one of these 4 categories. We're talking about tiny little muscle events, like a twitch you can't even see, small changes in blood flow, little shifts in your body's chemistry, and of course the big ones, general lifestyle stuff like how stressed you are or how well you slept.
Let's make this super practical. You know that tiny little muscle twitch you sometimes get in your eyelid or your leg? If that happens near a nerve, it can irritate it and cause a flash of pain. Or, say you're slouched over your desk, that can temporarily pinch a nerve. Even just being a little dehydrated can mess with your electrolytes, making your nerves a bit more trigger-happy. And yeah, a really stressful day can put your whole system on high alert, ready to overreact to anything.
Okay, so we've got a nerve misfire, and maybe it got a little nudge from an accomplice. But that's still not the complete picture. There's one more character in this mystery, and it's a big one, your brain. It doesn't just receive signals, it decides what to do with them.
This is so crucial to understand. Your brain basically has a volume knob for every sensation you feel. And your mental state, how you're feeling emotionally, can grab that knob and crank it way up. It can take a tiny, meaningless signal and make it feel loud, scary, and significant.
And this is how a really nasty feedback loop can start. It all begins with that tiny, harmless bit of neural noise. But if you're already feeling stressed or anxious, your brain is kind of on high alert. So it spots that little signal and zooms in on it. It puts a spotlight on it. And because of that intense focus, the sensation suddenly feels 10 times stronger than it actually is.
So, now that we've identified all the culprits, we get it. We understand the mechanism, so we can finally close the case. The last question is, what can we actually do about all this? How do we keep our internal system running nice and smooth?
So here it is, the final verdict. These glitches, they are almost always completely harmless. They're not a sign of a disease. They're just a normal, quirky feature of having an incredibly complex and sensitive nervous system. And honestly, just knowing that, just understanding that it's okay, is often powerful enough to break that anxiety loop we just talked about. And if you want to be proactive, here are a few simple things you can do. Notice how these all target those accomplices we mentioned? Checking your posture helps avoid pinching nerves. Staying hydrated keeps your electrolytes in balance. Managing stress and getting good sleep calms your whole nervous system down. And just moving your body keeps everything working as it should.
So I'll leave you with this final thought to chew on. We call them glitches, which makes them sound like an error, like a mistake in the code. But what if they're not a bug at all? What if they're actually a feature? A sign that you have a highly responsive, incredibly sensitive system that's constantly checking in on itself. It's kind of a cool way to reframe something we all go through.